Hello, in this video we will see about the substitution theorem related to current source. Substitution theorem related to voltage source is also there, that we will see later. So at first we will see the substitution theorem related to current source. So what is the meaning of this one? For example, you assume there is a network N and it is having two of the nodes are A and B, and in between these two we will take one element is available, E element is available, and it can be linear or non-linear. Okay, it can be linear or non-linear, and we know some information related to this one, that is the voltage across this element is V and current passing through this element is I. This is the information already known to us. Okay, so there is a network and A, B are the nodes related to that one, and in between A and B nodes there is a element E which can be non-linear also. And what is the voltage across the element? That is V, and current passing through the element is I. This is the situation. Now, without affecting the branch currents and branch voltages, we can do one thing here. That is, I have taken the original circuit like this. There is element V available across this one, I is passing. Now, what are the changes I am making is, I will connect one current source. If you connect like this, it will become another circuit. But I need the original circuit only. For that, I need to cancel this current source I. For that, I will take the same current I in the opposite direction. So like this I will take. Now, whatever the part we are representing here newly included, because of this one, the branch voltages and the branch currents available in the original circuit will not be affected. Because the parallel connection of these two current sources will become zero only, because those two currents I have taken opposite to each other. How it is possible? For example, if you take that parallel connection of equal and opposite current sources, what it will give actually? For example, if you calculate the current out of this particular parallel connection, that is X, for example, apply KCL at this node. Okay, so what are the currents entering into that node? Only I, that is related to this element. And what are the currents are leaving from that particular node? One is this I, second one is this X. Okay, so I plus X. So X is equal to 0 you are getting. So that means nothing is coming from this particular parallel connection of two equal and opposite current sources. So this will give open circuit only. Okay, current is 0 means I can say that is open circuit. So this is actually open circuit. Okay, so it will not affect by connecting this equal and opposite current sources to the original circuit. It will not affect, this connection will not affect any branch currents and branch voltages in the original circuit. So I can connect like that. Okay, then what we will do is, we will redraw the diagram in a different manner. See carefully. So previously we have, the network is like this. It is node A, it is node B, and here we have taken previously the element. Okay, now instead of taking that element, just I will take this current source, I am moving to here, and this element I am moving to this position. Just position I am changing. Because of that one also nothing will happen, because these three elements are in parallel. In parallel, we can connect one element first, another element second, and we can interchange those two. Because of that one, nothing will happen. So then I will keep the element, and another current source is then, and I'm not touching this one. It will be like this. Okay, then we have taken the voltage across element E is V, current passing through that one is I, and voltage across this one will be V only, because in parallel voltage is same, and this current value already we have given I. Like this, now we have made the changes. Now, if you see one thing, what is the current passing through this part of the circuit? What is the current? What is the current means? So for example, if you see in this particular path, current is going upside, current is coming up to here, the current I is coming up to here, then it is entering into the element only. So here in this particular loop only current is rotating like this. The current I, whatever the current I is coming from the current source I, it is going through the element like this. Okay, you can check the KCL also. So you will find no current in this particular path. No current in this particular path. Okay, so what I am doing is here in this area or in this area, no current is available. Okay, here current is equal to 0. Here current is equal to 0. And because of this one, is there any effect in the branch voltage and branch currents? Means no. Previously, you have the element here and across that element V voltage is there and through that element I current is passing. Now also same thing is happening. But in place of element, you have the current source. That's it. So because nothing is going in this area and in this area, we can cut that one. For example, take the scissor and cut this one, cut this one. Okay, then what is the remaining circuit? Here you will be having the network and this node A and B is there. Now previously you have the element, but you have the current source now. But same current is there and same amount of voltage is also there. So because of this one, nothing will be changed to the branch voltages and branch currents. Okay, so what we have done? We have started with the network and in between A and B, element E is available. Now we are ending with the we are ending with the current source in between the A and B. And same amount of current and same amount of voltage is available as for the original circuit only. But here we can say simply the element E has been substituted by the current source I. That's why it is the substitution theorem. Thank you.